Yeah, what we have here is super elevation. So, from definition, super elevation is the transverse slope that is provided on a horizontal curve, to offset the centrifugal force acting on vehicles. So, thus reducing the tendency of the vehicle to skid or turn. So this is just a slope provided so that because of the slope now it tends to help the vehicle from skidding or overturning. So you can see from the vehicle we have here, we have our resultant reaction, which is designated by R, then the centrifugal force, which is Fc, then the weight of the vehicle, which is acting downward, which is designated with W. So where W is the weight of the vehicle, Fc is the centrifugal force, then R is the resultant reaction, then our super elevation is designated by E, small letter E, then G is the acceleration due to gravity, then we have our V to be the speed of the vehicle, and the R, that is capital letter R, as the radius of the curve. So we'll move to the cross section of the super elevated road. So, and from here, from this picture, you can see the height, then you can see the pavement width. So the pavement width is designated by small letter B, then the height is designated by H. So your super elevation is equals to H over B, where H is the vertical height difference between the outer and the inner edge. We have two edges of the road. So we have the outer edge and the inner edge. So, and your slope is from the outer to the inner. You understand? So our super elevation is going to be E is equals to that H, that is the vertical height between the inner and the outer edge, over the B, that is the pavement width. So then we have to use this relationship. So for a vehicle moving on a super elevated curve at equilibrium, whereby there is no skidding tendency, so you're going to make use of this formula E, which is our super elevation, plus F, which is equal to V square over 127 R, which is our radius. So where E is the rate of super elevation, then F is the coefficient of side friction, then your V is the speed of the vehicle in kilometer per hour, then our R is the radius of the curve in meters. So we have the maximum and the normal values, that is IRC values. So we have the road types, plain and rolling terrain. So the maximum super elevation value is 7, then the normal is 5, then our maximum coefficient of friction is 0.15. Then for Mediterranean terrain, we have 10, we have 7, then we have 0.15. So basically, even for steep terrain, the coefficient of side friction is still 0.15. So here are the things to take note of. Super elevation is provided only on curves, so it's not basically on your straight roads that you provide super elevation. So super elevation can be provided mainly on curves. Then it is raised from the center of the line towards the inner edge. So your super elevation is also from the center of the line to the inner edge. Then it improves safety and comfort and stability of the car. So in as much as you are riding on a curve, you still enjoy that safety, comfort, and the stability because of your super elevation that is provided. So super elevation is very, very important on the road, especially on curves, because the centrifugal force is very, very active on curves. So that is why super elevation is provided, so that it helps to stabilize your vehicle in as much as you are still riding on the curve, but the weight, it will still be acting downward. You still have your reactions, but that super elevation tends to suppress that centrifugal force, which helps to keep the vehicle from skidding. All right.